Hey everybody, in this lesson we're going to talk about how to name ionic compounds, as well as how to write their chemical formulas. So we have strategies that we have that we're going to talk about with regards to writing these names. But first of all, let's talk about this in terms of multivalent versus non-multivalent. So in our periodic table, we have what we call the multivalents, and they're called multivalents is because they have multiple charges. And that actually will change how we write their names. We have the non-multivalents, which are the metals in the first two columns, and aluminum, zinc, and silver. Those tend to not have multiple charges. Well, if you look at something like iron, iron has a +3 charge and a +2 charge. So those are what we call the multivalents. So because of that, we have different strategies for writing their names. So first of all, we're going to talk about chemical formulas. How do we write the chemical formulas? Well, we start off with rule number one, or step number one. We always write the metal symbol first. But then the second thing is, what we add to the symbol is we also write the charge as a superscript. Superscript is just like an exponent. So we write their charge as a superscript. So we write metal symbol first, non-metal symbol second. Then what do? Well, we know that compounds are neutral. And because they are neutral, we now got to make sure we find a way to balance their charges. So we balance charges by finding LCM. And that is a very important step. We got to use LCM now. LCM stands for lowest common multiple. AKA, we look at the multiple of each of them and try to find the lowest one. So for example, the LCM of 2 and 3 equals 6. Or if you want to find the LCM of 1 and 2, that is 2. Because 1 can turn to 2's, and 2 is already the lowest common multiple for that. So that's what we have. We got to find and balance the charges by finding LCM. But now step 4. Multiply each ion by, or not, multiply each ion to, so their charge equals LCM. And then the last step is write each multiple as a subscript. So at the bottom right now. So we are going to show this with some examples. But we got to make sure, the big thing is, ones are not written. Because just like exponents, for example, where we don't write the exponent 1, we're going to assume it is there. So let's try our examples. Potassium oxide. Potassium is a metal. Oxide is oxygen. It's the other non-metal. So potassium right here has the chemical symbol K. It has a +1 charge. Oxygen has a chemical symbol O, and it has a -2 charge. So that's what we have first. We have K +1 charge, and we have O -2 charge. So you see how here we have unequal charges. So what we do now is we look at the LCM of their charges. What's the LCM of 1 and 2? It is 2, which means we will multiply each of them to become a charge of 2. So how many potassiums do I need to become a +2 charge? We need 2 of them. How many oxygens do I need? I need 1 of them. So now our chemical formula becomes K, and now we write the multiple of each as a subscript. Subscript being the bottom right. So K2, there's 2 potassium and 1 oxygen. And we don't need to write the 1 because it's assumed. So that is our first element, our first compound. Magnesium phosphide, let's look at it. Magnesium right here has a +2 charge. Phosphide comes from phosphorus that has a -3 charge. So let's write those down. Magnesium has a +2 charge and phosphorus has a -3 charge. What is the LCM of 2 and 3? That is 6. So what I do here is I want to find what I could do to become +6, which means I need 3 magnesium. What do I need for phosphorus to become a -6 charge? I need 2 phosphorus. So now I write these multiples as a subscript. So it becomes Mg3P2. And that is our chemical formula for magnesium phosphide. So let's switch gears now. What about if we write it for our multivalents? Well, if it's our multivalents, in this case, it is, the rule here is, it's same as non-multivalent. But this time, what is new is that our metals charge is written as a Roman numeral. So how do we remember Roman numerals? Well, I is equal to +1, 2 i's is +2, 3 i's is +3, 4 i's is +4, or not 4 i's, IV is +4, and then V is +5. And there's more of that, but usually that's how high we usually go. So let's look at an example. Tin, and that is 4 sulfide. So what does that look like? Well, tin, if you look at our periodic table, tin actually sits right here. So here we have tin 4. Notice how tin has 2 charges, +4, +2. In this case, the tin we're dealing with right now is +4 charge. So that is Sn +4. Sulfide is right here. Sulfur has a -2 charge. So it's sulfur -2. So again, what's the LCM of 4 and 2? The LCM of 4 and 2 is actually 4. Because each of these can become a 4. So how many tins do I need? I actually only need 1 to become a +4, but I need 2 sulfurs. So my chemical formula becomes Sn. Don't need to write the 1 because it's already assumed. SNS2. Let's look at our next example. Iron 2 oxide. Iron 2 means it's Fe +2. Oxygen from our previous example is O -2. What's our LCM of 2 and 2? It's just 2. So I just really need 1 of iron and 1 oxygen. So my chemical formula becomes FeO. So this is the way we write chemical formulas when we're dealing with multivalents. What about polyatomics? Well, first of all, what are polyatomic ions? Polyatomic comes from the word poly, meaning many. Many atoms are ions. So if you look at your periodic table, you're going to see right here, these ones are polyatomic ions. So if you look at our polyatomic ions here, we have, for example, ammonium, which is our only positive ion, that's a polyatomic ion. It is made up of nitrogen and hydrogen, but it carries a +1 charge. Let's say, for example, cyanide. Cyanide is Cn minus, multiple atoms, carries a charge. Hydroxide, OH minus. Phosphate, PO4, 3 minus. So these are our polyatomic ions. So what do we do? To write the chemical formula of these polyatomic ions, it's same as before. But now the rule is the polyatomic ions act as a single unit. And because of that, they carry 1 charge. They carry a single charge. Okay, that's interesting. But the other rule is, and this is a star, when you have multiple polyatomic ions, like for example, when you write the multiple of them, you use parentheses. And I'll show you an example of that. So an example of that would be, let's say, for example, you have, I don't know, let's say you have 3 NH4s, okay? You have 3 of them. To write this, you do not write this, NH4, 3. That's incorrect. Why? Because for someone, they might mistake it that there's 43 hydrogens. What you do is you write NH4, parentheses, 3. This is the way to show that. So let's look at an example of something that we deal with that looks like this. So lithium phosphate. Lithium is an element. It's Li. If we scroll up really quickly, it's Li plus 1. But phosphate is PO4, 3 minus. So we have Li plus 1, and we have phosphate, which is PO4, 3 minus. So here we got to find the LCM of 3 and 1, which is 3. So what do I have? I need 3 lithiums, but only 1 phosphate. Because I only have 1 phosphate, I do not need parentheses. So I write this now as Li3PO4. If I look at my next example, iron 3 nitrate, let's take a look. Iron 3 means it's Fe plus 3. Nitrate, polyatomic ion. Nitrate is right here. That's NO3 minus 1. So it's NO3 minus 1. What's the LCM again of 3 and 1? It's 3. But this time, I only need 1 iron and 3 nitrates. So what I have here is I have Fe, just 1, don't need anything with it. But nitrate, I have 3 of them. So I need parentheses, NO3, 3. Now, what are some things I need to be careful of? Because there might be scenarios in which I might forget. Well, in this case, the biggest one that you should always not mess up is NH4 plus versus NH3. Because they have very similar names. NH4 is ammonium ion. It is an ion. It's a polyatomic ion, in fact. While NH3 is ammonia. It's a compound. It's neutral. It doesn't have a charge. So that's a very important one we should definitely keep an eye on. The other one that we should be careful about are the polyatomic ions that are, for example, you see here, HCl3 minus. It could be called hydrogen carbonate, but the more common name is bicarbonate. Just like this one, hydrogen sulfate, more common, bisulfate. Bisulfide, bisulfite. All right? So those are ones that you should be careful about. Well, let's flip backwards now. What if you're given the formula and you're asked to write the name? Well, for non-multivalent, this is very simple. Very simple. First off, find element name from symbol. And we easily do that again from the periodic table. So from our periodic table, just find the name from its symbol. Remember, metal name first, non-metal second. That is always the rule in this case. Okay. The second rule is the non-metal's ending changes to "ide." So that means, for example, oxygen becomes oxide. So what do? Well, for the non-metals, you keep first syllable plus "ide." For metalloids, or the semimetals, the ones that hug the staircase, you keep 2 syllables plus "ide." So I'll show you that example with our periodic table. So for example, oxygen, a nonmetal, ide, oxide. Chlorine, chloride. Fluorine, fluoride. Bromide. But the more you hit the Semimetals, the metalloids, they keep the first two syllables. So silicon is not silide, it's silicide. Notice the first two syllables, sila. Arsenic, you keep the arse, so it becomes arsenide. Tellurium becomes telluride. So these are the semimetals. So they keep the first two syllables. So let's practice that. Let's look at this. CaCl2. CaCl2 is calcium, and then Cl is chlorine, so it becomes calcium chloride. So we actually don't care about how many chlorines we have, because that just means how many we need to balance out the charges. We just care about its name, which is calcium chloride. If we look at SRO, SR is, if you look at it, SR is strontium. Strontium, and O is oxygen, which is oxide, so that becomes strontium oxide. If we look at now, what happens if you deal with the multivalents, which are these ones? You define the Roman numeral, because that's the difference between these multivalents, which need Roman numerals to state which one of these you're dealing with, versus the non-multivalents, which only have one charge. So what do you do to write the chemical name? So first of all, the first step we gotta do is we should write out the ionic name as before. So if it's, for example, iron oxide, we write out iron oxide. We just need to now find that Roman numeral. So to find Roman numeral, we gotta do a bit of math backwards. How? How do we find that Roman numeral? Well, to find the Roman numeral, the metal's charge changes, right? Manganese has 3 charges, right? So because of that, we don't know which one it is. But what doesn't change its charge? Wait, the nonmetals. The nonmetals also don't change their charge. So what we're going to do is we're going to use the nonmetals here to find the charge of our metal. How? Well, if we know that between the metal and nonmetal, it is neutral. And because if it's neutral, it means whatever your negative charge here is must equal your positive charge. So that's what we're going to do. We're going to use a bit of math. So to find Roman numeral, our first step is find nonmetal and charge. But step 2, multiply number of nonmetal with its charge. Because what you just did here is you found the total negative charge. Because in a compound, compounds are neutral. And if they're neutral, what that means is total negative charge equals total positive. So, what you have now is take total positive, divide total positive by number of metal. And by doing that, you just found your metal's charge. And then what you do now is you write that charge as your Roman numeral. So let's practice that. Let's look at example number 5. So we have Fe2S3. So we're going to ignore the Roman numeral first. We know that Fe right here is iron and S is sulfur. So it's some form of iron sulfide. But we got to find that Roman numeral that goes in between. So what do? We look for sulfur. Sulfur right here, we have sulfur has a -2 charge. So we look at sulfur, it has a -2 charge. How many sulfurs do I have? I have 3 of them. So I multiply this by 3. So our total negative charge is -6. which means our total positive must equal positive 6. How many irons do I have? I have 2 of them, so I take this and divide it by 2. It equals positive 3. This right here is our iron's charge, which means it becomes iron 3 sulfide. If you want to try the next one, try it out on your own, but I'm going to do this, so you can pause the video, but I'm going to do this right now. So this next one is CuCl. Cu is copper. Cl is chlorine, so it becomes copper chloride. But we don't know, again, what that Roman numeral is in the middle. So what we do, we use chlorine's charge. Chlorine has a -1 charge. So we look at chlorine, we go -1. How many chlorines do I have? I only have 1. So our total negative charge is -1. What must our total positive charge be? To balance it out, it must be +1. How many coppers do I have? I only have 1. So 1 divided by 1 is still +1. So what does our copper become? It becomes copper 1 chloride. Our last example is what happens if we now need to write the names of our polyatomics. Well, this is actually the easiest one. The reason why is because, number 1, same as before. So you still use the same rules as before, but for number 2, do not change polyatomic name at all. So don't change this ending to "ide." Okay? Do not change this ending to "ide." So do not change ending. So the easiest one. Let's take a look at our example here. Ag3PO4. So Ag is silver. And yes, silver is in the polyatomic ion, but it's actually not a multivalent. It has only +1 charge. So we look at silver. This is silver. Now what is PO4? PO4, if we scroll down to our polyatomic ion chart, we will see that it is PO4 right here, is phosphate. We just write it as phosphate. We don't have to change the ending at all to phosphide because that will be just phosphorus itself. This is silver phosphate. We're done. NH4, oh, that is right here. That's ammonium. Don't change anything about ammonium. S is sulfur, and now we change the sulfur. That's an element. Because it's an element, we need to change its ending. That becomes sulfide. Now some students go, can I write this as SULPHIDE? There's nothing wrong with it. The F or the PH, that's just really a British versus American way. You could write either or. It's okay. As always, make sure you keep yourself safe and healthy, and I'll see you soon.